All right, what's going on, everybody? Today we're doing another LeetCode problem. This one's called search in rotated sorted array. It's a medium. Let's get into it. So we have an integer array called nums. It's sorted in ascending order. It's got distinct values. Prior to being passed into our function, it's possibly rotated at an unknown pivot. So basically, that nums array is going to be, yes, it's going to be sorted, but it can also be pivoted, meaning this would be a non-pivoted sorted array. But if that was pivoted, for example, we can have the lowest number starting, and basically the lowest number and the greatest number can be somewhere in the middle of the array. So 1/2 is going to be sorted. You're basically going to have two segments that are increasing, and then a pivot between them. So given the array nums after the possible rotation, and then they're going to also give us an integer called target, they want us to return the index of target inside of the nums array if it exists. If it doesn't, they want us to return -1. So they want our algorithm to be big O of log n runtime complexity. And basically, this kind of suggests for a sorted array that they want us to implement a binary search algorithm of some kind. So we're basically going to implement a modified binary search algorithm to account for the array being pivoted or being rotated. So so optimal approach here is going to be to use a modified binary search to find target in big O log n time. And then the space is going to be constant because we're not going to need any additional data structures. So let's go ahead and run through an example here before we get into the code, just to try and understand this problem a little bit better first. So I'm just going to use this first example here. And the variables we're going to be using are, let's see, I'm going to save that line so I can mark the pointers. But we're going to have a left pointer, we're going to have a right pointer that's going to be equal to the, let's see, this array is size 7, so it's going to be equal to the 6th index. We're going to have a midpoint, that's basically going to be the average of the left and the right pointer, so 3. And that's going to be it for our variables. So our left pointer is going to start here. Our midpoint will be there, and our right pointer will be there. I don't know why it likes to add periods here. Maybe that's a setting I can turn off. Need to find that because it's a little annoying. But so anyways, yeah. So the first thing we're going to do basically when we're looping is we'll check if our midpoint is equal to the target. If our midpoint's equal to the target, then we can just return the midpoint's index, or which is the midpoint itself. So that's when we find the answer, and basically we've got to come up with some kind of way to adjust our pointers to get closer and closer to the answer in a logarithmic nature. So the first question we're going to ask essentially when we have these pointers at each iteration is it's going to be, okay, is this part of the array, is the bottom half of the array going to be the completely sorted portion, or is it going to contain the pivot? The way to know if it's completely sorted or if it contains the pivot is basically to just see if the midpoint is greater than the value at the midpoint is greater than the value at the left pointer. So if that's the case, we know this part of the array is sorted. And once we know that, we can just say, okay, well, is the value of our target greater than the, is it greater than the midpoint? Or is it less than the left value at the left pointer? Because basically we have a sorted range here. So if we check if it's greater than the top of that range or less than the bottom of that range, we know it. We'll know if it goes in there or not, right? or if it could potentially be there, right? Because it might not be there, but we'll know for sure because the pointers will eventually overlap. But anyways, yeah. So that's kind of a little bit of the idea. I'm just gonna run through this full test case here. So yeah, so the first thing we're going to do is we're going to see, is this left portion of the array sorted? It is. So we're going to basically compare the target. So is the target greater than 7 or less than 0 or less than 4? It's less than 4, so we know it's got to be on the other part of the array. So we're going to adjust our pointers to search the right half of the array. So the left pointer is now going to become mid +1. And then our mid pointer will get updated to, let's see, so left pointer is going to be 4, and I actually didn't have to erase the right pointer, it's going to stay as 6, and then our mid point will be 5. Okay, so now we're going to again check, okay, is the left portion of the array sorted? Yes, by the way, we checked if mid was equal to target first. It wasn't. So we're going to see if the left portion of the array is sorted. It is. So we'll compare, okay, is target less than 0? Or yeah, is it less than 0? No. Is it greater than 1? No. So it's got to be in this portion of the array. So we're going to move our right pointer to be the midpoint -1. So those are actually going to overlap now, but our loop conditions will actually be, well, right is greater than or equal to left, so the loop will keep going at this point. So right's going to also be at 4, and the midpoint will be 4 as well because it's the average. So I'll make another line for the midpoint here, so those are all overlapping. Okay, so is the left portion sorted? Yes. Yes, it is, because we're going to have we're going to be doing a greater than or equal comparison on the value of mid and value of left. So we would consider this to be sorted. Okay, is mid equal to 0? And we don't even have to do that. Yeah, I started going the conditions. The code wouldn't even reach this. So the first line of code in the loop, or one of the first lines, is going to check if that midpoint equals the value at the midpoint equals the target. It does, so we would return, let's see, 0, 1, 2, 3, 4. We would return 4. So that's it for this walkthrough. I would go through another, but it can get kind of time consuming going through these. So I think it might just be better to write the code now. So we're going to do our left pointer and our right pointer like so. It'll be just pointing to the last element there in the array. And then we need that mid variable. So we're going to loop while our right pointer is greater than or equal to our left pointer. And then the first thing we want to do is just calculate that midpoint. So it's going to be the average of, those 2 pointers. And then we can check first if our target is equal to the value at the midpoint. And if it is, we can just return the index of mid, and that will be the result. So now we need to do some stuff to update our pointers. Now remember, basically what we want to check first for our algorithm is that lower left half of the array sorted. So to do that, determine that, we can just say, is the value at the midpoint greater than the value, or greater than or equal to the value at the left point? That equal to is important, as we saw in our run through. So if this is the case, we know that the left portion of the array is sorted. So we basically want to see if the target is going to be contained in that left range. So to check, we can just say, so if target is greater than the top of that range, that'll be, I'm noticing I have a typo here, that'll be nums mid, right? It's the top of that lower left half. Or if the target is less than the lower half of that range, or the lower bound of the range, so nums left. If it's not contained in that range, that's basically what we just asked, then it must be on the right side of the array. So we'll search the right half of the array by shifting the left pointer to be the midpoint +1. Otherwise, we know it has to fall in that range if it exists, so we're going to keep searching to the left. So we'll move our right pointer down to the midpoint -1. And I called that variable mid, not midpoint, so I need to get rid of that. Okay, so now we're going to have an inverse situation, right? So if the left portion of the array is not sorted, we know it's going to contain that pivot point where the greatest value meets the lowest value. So with that being said, so basically we know, if this is not true, that the midpoint has to be less than the value of the left pointer. So, or the value at the array in the left pointer. So basically we can, so if the pivot point is in the lower half of the array on the left side, then we know that the right portion of the array, like the upper half of the array, must be sorted, right? Because there can only be one pivot point. So if the upper half of the array is completely sorted, well, we can do the same sort of logic here, but on the upper half. So if the target is greater than the upper bound of that upper half, which would be the right pointer, or if the target is less than that lower bound of that increasing portion of the array, so that would be mid, we can basically, so if the number is not contained in that increasing portion of the array, then we know it's got to be in the other side, which is going to be the bottom of the array. So to search the bottom of the array, we'll shift our right pointer down to mid -1. And then if it is in that range in the top half of the array, then we're obviously going to want to search in that range in the top half of the array. So we'll shift our bottom pointer up to mid +1. So let me zoom out so you can see all of this, because it's kind of getting to be a lot here. After that, remember, we want to return -1 if our pointers are overlapping, because what will happen if the nums mid is never equal to target, our pointers will overlap. We'll reach this part of the code and we'll just return -1 if the element is not present in the array. So let's go ahead and run this and see how we did here. So it accepted those initial test cases. Let's check out the percentages. So it beats 59%. With runtime, 35% with memory. I cannot help but try and run this again, because I know we can get 100%. I know we get 100%. All right, okay, I guess not. We're at 59.96 twice in a row. We're gonna have to roll with that. So did a little better on memory though. So I hope this video helped you understand this problem better. If it did, please leave a like and subscribe. And I'll see you guys in the next piece.